So without further ado, I'd like to introduce you to a fantastic person, scholar, and a colleague and friend who is joining us today to talk with you about the challenges of ChatGPT and AI in healthcare. Professor Marcel Salathé is a Swiss scientist noted for pioneering efforts in digital epidemiology. Currently, he's a professor of digital epidemiology at the EPFL, that's the Swiss Federal Institute of Technology in Lausanne, Switzerland. And he's a former affiliate at Stanford University. His interdisciplinary work combines biology, digital technology, and AI to tackle pressing health issues. During the COVID-19 pandemic, Marcel was a member of the Swiss Science Task Force, heading the digital epidemiology group. He played an instrumental role in developing a global digital contact tracing protocol, leveraging technology and to effectively mitigate the spread of the virus. I had firsthand knowledge and honor to be able to work with him and also hear him speak. And I'm very, very glad that he's able to take time to come and share his experiences with you. Thank you, Marcel, for being here. And I'm going to turn the floor over to you.
Thank you very much. Thank you for being here so early, and thank you for the invitation and the kind words. Yeah, very excited to share a bit my experiences and learnings with ChatGPT and relevant so-called large language models, or LLM. These are obviously very much sort of thoughts and experiences in progress. Research is coming out using these LLMs. I think the world at large is quite confused about this technology. That's not to say that I'm not. I'm obviously just as confused as everybody else, but that there the very clear statements being made about what the future of LLMs will look like, which are almost all wrong, almost certainly. Some will be right, and of course the trick is now to figure out which ones those are. But it's very reminiscent of the early days of the internet, where I can't say very much because I wasn't very intellectually present at the time. But when you sort of read the history a bit of the late 80s and early 90s and how the internet came along and how it was dismissed very early on for things it wasn't, it's very reminiscent somehow of what LLMs, I think, will be. So the picture here that you see is completely nonsensical. It's I asked ChatGPT for a prompt about this title, which I then fed into Midjourney, which is a generative AI for images, and that's what came out. And as you can see, the reason why I'm showing this is not just because it's kind of cute, but because it's very reminiscent of what this technology does. It kind of makes sense superficially, but then when you look at it, it's really not very meaningful. And I think that's true for many things also with respect to text. But now to throw out this baby with the bathwater and say, well, therefore this technology is completely useless, right, is a serious categorical error. All right, so let's make sure we're on the same page. The few people in this room who have been in Basel a few months ago will recognize many of these slides. Again, this is work in progress. I updated those, of course. So these LLMs are deep learning models. They have a lot of parameters. The modern versions have billions of parameters. They're called GPT, mostly because they're generative, pre-trained, and transformers. It just means generative means they can actually generate things, which is, of course, what we're talking about. Pre-trained means that they have been trained on a lot of data, and we'll talk about this a little bit. And that's actually the very costly part, and the reason why the main actors in this space are commercial and not academic, for example, because it just simply costs a fortune to actually train such a thing. And then transformer is just the underlying structure of the technology that's being used. It was published about 6 years ago now in a paper called "Attention is All You Need," because of a so-called mechanism that's called the attention mechanism. Won't go into the details here. This is a very short history, right? GPT-1 came out in 2018. Nobody really cared too much about it. It had 117 million parameters, which at the time was considered very large. GPT-2 came out in 2019. about 10 times larger, 10 times more training data, still was by and large an oddity. I mean, sort of interesting from a computer science perspective, but not really useful. Then in 2020, something happened, but most people really didn't take notice because they were focused on something else, which of course was the COVID pandemic. But this GPT-3 was actually quite interesting. It started to generate sentences that were actually relatively human-like, and it could create text where you would say, well, you know, it's not correct, obviously, but it would be hard to say, increasingly hard to say. And you can see, right, the massive increase in parameters. Then GPT-3.5 came out, and this is where everything changed, when this was productized as ChatGPT. Okay, so if you interact with ChatGPT in November 2022, you're interacting with a model called GPT 3.5. It's now much more powerful, but we have much less data because now it's being commercially used by OpenAI in particular. And then GPT-4 comes out in the March of this year. It supposedly is actually 8 models working at the same time for a total of 1.7 trillion parameters, but that's you know, unconfirmed. I'll keep going. This technology, again, does not just sort of drop from the sky and somebody had a brilliant idea under the shower, but it's something that's been going on for many, many years. And starting from this transformer technology, which itself, of course, would have a huge root going back, including to places like Ticino, one should always add. You can see these very, very different models that came up, and we're really just talking about this branch up here, GPT-4, and I'll say a few things about Llama and Bard. But so this is a very dynamic area. So what does it do? Fundamentally, it predicts the next word or token, as they say, in that world. But you know, you can think of a token as a short word, and a longer word would maybe be 2 tokens. But the idea is that you have a text like this: Finance Minister Karen Keller-Sutter hailed the very strong acceptance rate for the plan to amend the constitution so Switzerland can join the. And now the question is, right, what's the prediction now of the model for the next word? And when you actually ask it, I mean, you have to squeeze it a little bit to reveal it, but when you do, it says, look, these are the next word predictions and the probabilities. It is going to sample from those probabilities, which is why when you enter a prompt in ChatGPT and I enter a prompt, we get different responses. There's ways to sort of freeze that, but annoyingly, there's no way at the moment to freeze that to 0, just like when you would write a computer program and you would set a random seed. So even if you have a random simulation with random events that everybody can actually replicate it. This seems like a trivial detail, but it's kind of important because it makes this kind of research non-replicable at this stage in the strict sense. In any case, so that's pretty good, right? But actually, so you can see here the network learned, right, on all the text that's out there, and most of the text here is about Switzerland joining, right? It's typically the EU. So this is why it comes up with the EU. If you give it a longer text, and now I just added the paraphrase before, where there's some talk about OECD, and now you ask it, you know, what's the next word? If you have that information, then it correctly uses OECD, it predicts OECD. So that's just to show that it's, of course, not just predicting the next word from the previous word, right? Otherwise, it would very quickly get nonsensical, like the phones in the beginning who tried to predict your next word as you were texting. It is taking into account everything that came before, and this can be very long. Now we can go into almost document or book size, and more importantly, it can actually make sense between the words so that it knows what it referred to in the previous sentence and things like that. Again, I don't have time to go into technical details how this works, but that's how it essentially works. And then by and large, right, you have this input, you feed it to the LLM, it makes a next word prediction. Now it adds that to the previous input, and again, it makes a next word prediction for the next word. Again, it's tokens, but it doesn't matter. then you do that again and again. And so it iteratively does that until, you know, it stops. And there's a way, right, to make it stop earlier or later. And that's the context, this whole input and output and the system messages that you can give it. And at the moment, GPT is limited to about 12,000 or 24,000 words, depending on which model you use. But there are some LLMs, particularly Claude, which is a new one that has 100K context. That gets very interesting because now we're talking about roughly book length. So now you can basically feed a book to an LLM and it can reason, in quotes, about the book. So again, it's very important to understand that these are models, right? We're talking about the models. And you can use them if you want to use them, you know, personally or professionally. You can access them through API, which has a cost. But you can also now access GPT-4 API, which wasn't the case in the beginning. But most people, when they talk about this stuff, they talk about their experience with ChatGPT, which is an application, right? It's in a browser or in a mobile app. It itself, of course, constantly, ChatGPT, the application doesn't do much. I mean, not nothing, it's important, but it just then passes these requests to the model, to the GPT model. So when you use ChatGPT, the free version, you're actually interacting with GPT 3.5. If you're using the paid version, you're interacting with GPT-4, which is a much stronger model. Just to get the terminology straight, right? Now, I keep showing this example in the public health context because I find this very interesting, and it reflects on the work that we do. For example, I've been doing a lot of Twitter analysis. I'm not doing that anymore because the data is not accessible anymore. We're doing it with other textual data. So things that have interested us for a long time is, for example, vaccine hesitancy, vaccine sentiment, stance, and so on. And so I give ChatGPT this tweet, right? I'm so angry that the vaccine is not yet available in my country, and ask it how to interpret it in terms of sentiment and stance. This is a classical example, right? Because it is a negative sentiment, right? Somebody's angry. But they're angry because they can't get the vaccine yet, which means their stance towards the vaccine is positive. So you can't just do a sentiment analysis and say, wow, people really don't like the vaccine. Look at this negativity. So, and as you can see, it actually does that correctly. This was not surprising to me, but, you know, having trained some machine learning models, this has actually been quite difficult. And now this thing just comes out of the box like this. Like, okay, this will make our work much simpler. However, I made this slide en route to a conference in the Netherlands. So I said, you know, I'm going to just take a Dutch tweet. And I don't know how many people in here or online read Dutch or can understand it. I don't. It translates it apparently perfectly, Dutch speaker tell me, and correctly assesses that somebody's really ranting here about the vaccine. And then it reasons, right, that, you know, they probably believe that this is not effective, and therefore that's a rather negative stance. So I'm showing this because this was always a blocker for us. We always had people coming from all parts of the world and say, hey, can we use your sort of Twitter sentiment technology to look at what's happening in our part of the world? And I always had to say, well, we have to retrain the models, and we have to make sure they understand. Right? I'm going to use a lot of this when I say understand. And that's just always been a blocker. Now, again, it just comes out of the box. Just speaks pretty much any language out of the box. Not any, but so many. And then this to me is the kicker. I passed it a joke that you can find, right? Just Google vaccine jokes. Those who think the COVID-19 vaccine will modify their DNA should see it as an opportunity. So now the question is, can it pick up on irony, humor, right? Things like that. This was impossible pretty much before. Now, we're not going to read all of this, but if you take a look, right, there are things like this appears to be sarcastic, right? The author seems in favor, but it implies that they are aware of the misconception. They might use humor to highlight the absurdity. Right? So this is stuff that that just wasn't in the cards until a year ago. And most people said that's probably 20, 30, 50 years out. This right, would be a clear passing of the Turing test with flying colors. I think most humans might not pass that test. And yet we're somehow thinking, well, you know, this is just another piece of technology. So this still fascinates me how we react to this technology. But again, for my work, if I now want to use Twitter or any other textual source to analyze and interpret this data, now I have something that's just very good out of the box. And that's, I think, going to change a lot of things. So this has led to a new terminology called prompt engineering, because when you interact with these models, right, as I showed, there's an input, you pass it in, and there's an output. Now, it turns out that, as often people said, right, garbage in, garbage out, the quality of your output very much depends on what you input, the prompt, the so-called prompt. That has led to people thinking that there's something like prompt engineering, although it's a slightly misleading term. And I want to say a few words about it. Now, there was a lot of hype, right, that prompt engineers like the job of the future. And, you know, Anthropic, the creator of Claude, had job positions for starting at $250,000 a year for a prompt engineer. So correspondingly, right, this caused a lot of excitement in the system. John Brownstein is a colleague and the digital epidemiologist at the Harvard Medical School, always sort of, you know, one step ahead. And very quickly, they actually started recruiting for a prompt engineer, right? So you know, it's a good example of how quickly these things are happening. Now, what does it mean? Here's a simple example that you can test with the API. If you ask GPT, no, sorry, GPT, right? GPT. If you ask GPT and say, you know, the prompt is 23 times 34, it will correctly say 782. Now, what it's very crucial to understand here that nobody will be doing math in that model, right? It's just words. It's just strings of characters. And this is the prompt, and the most likely word or token is 782. Nobody has done any math. It just happens to be correct because probably you can find a lot of instances on the web where 23 times 34 is associated with 782. Now, if you subtract 12 from 782, as you very well know, this is 770 and not 742, but it very quickly says it's 742, just to show, right, that it's not actually doing math. Now, this complexity explosion here, and very quickly with 3 numbers, right, there's just too many combinations to really find any of them on the web. So it couldn't have learned just by repeating what is the correct response. And so it just says something that's not actually correct. If you do this in ChatGPT, the software will, of course, recognize there's a mathematical expression, and it will hand it to the appropriate tool, which is a calculator. And then it will give you a correct response. Or it will use a trick behind the scenes, which is to say, work through the problem step by step, right? You just add that to the prompt. And now it says, okay, first we need to perform the first multiplication, then we subtract it. And in the end, it arrives at the correct solution. So just by changing the prompt, right, you actually get the right result. Now, again, if you do this on ChatGPT now, it will just recognize that this is a mathematical equation. And so it will just, ChatGPT will insert, right, that it should reason behind the scenes step by step, and then the model will give you the correct example. So anything we find out, and we're literally finding this stuff on a weekly basis, right, how a certain type of prompt can improve a result, will very quickly be productized into the ChatGPT and other frameworks. So you want to be able to see it. This is called chain of thought prompting. Okay, another fun thing that people have tried and that really works well, and that tells us something, is to use personas. So you can basically, again, I don't want you to read it except the first sentence, right? I can instruct the GPT model to be someone. Again, it has no soul or anything, but the instruction then I can use it, right, to then really do things like language learning and so on. Now, of course, I could also say you're a medical doctor or you're a public health expert, and here is the corresponding question I'm asking you, and you will actually get better responses. Now, something that I've just recently come across, and maybe I'm late to the party, but I don't think I am. This is a conversation, right, between you and the technology. So there's a lot of examples where you give the LLM a role, but you can actually also take the role yourself. So I'm not a medical doctor, but I increasingly tell ChatGPT I'm a medical doctor. And here's why. So this is a prompt, right? Prompted, if you forgive the joke, by a recent glucose meter I had on my arm for research we do. I said, look, I see a spike. I even made a typo, right? It's 9 millimole per liter. I see spike going up, right, to 9 millimole, and then it rapidly falls back to 5. How do I interpret this? I know how I interpret this. I just had a meal. It goes up. Insulin kicks in. It goes down. I'm just asking a question here, right? Now, I'm going to contrast this with a slightly amended prompt where I say, I'm a medical doctor. Okay? So if I just give this without the medical doctor, it will basically tell me two things. The first is the correct description of what's going on, right? After meal, there's a temporary increase. It goes down because insulin kicks in. However, please consult a medical doctor. There's individual differences. Please review the guidelines, any concerns and so on. I mean, thank you, right? It's of course the responsible thing to do, but it's the kind of thing that it's learned on the internet, because on the internet, almost any serious medical information has all these CYA disclaimers all over it, right? That it's a one size fits all, and so it really needs to respond in a way that it learned on text, right? That basically is very simple, everybody understands it, and it immediately says, please go see a professional. So if I just add, I'm a medical doctor, and I'm not going to ask you to read what's coming now because you can't, but basically, right, the fundamentally different response here, because it gives me a bunch of differential diagnoses, and then it sort of says, here's what you should actually now consider from different perspectives. And then in the end, of course, a slight disclaimer, every patient is different and so on, but I'm getting really serious information here. Now, the point is not to dwell too long on this, but just to say, right, such a slight change in the input and a dramatically different output. And I think that's why people have so different experiences. And when you read the news and everything, and people say, what is this ChatGPT thing? It doesn't work, right? Well, that's partly the reason, right? Your experience can be so fundamentally different by how it's being used. Now, speaking of use, just one or two examples in the medical domain. This was an early paper that made quite the splash. It's been redone in multiple contexts. Here, patient questions were compared to the LLM. The LLM's response was compared to an actual physician's response. Long story short, right, the finding at the time was that not only was the chatbot more empathetic, which perhaps isn't overly surprising, because it's not tired, it's not stressed. It's just a machine, right? But it is also, in terms of quality, it was actually rated higher, and it was rated higher by other physicians. So it's an important finding with lots of caveats. And this was early on, right? This wasn't even the latest model. Similarly, more complex diagnostic challenges. This is something that the New England Journal does regularly, right? Since the 1950s, has these very complex challenges. And here also you can already see it just means, you know, how many of those it got right, and most of them it got right, but some of them it didn't. But it already, right, this is sort of very, very sort of challenging work in the medical domain that it already can perform extremely well on. So that's super impressive. Google is working very actively on medical applications, more so it seems than others, and has recently released a network called MedPalm 2, which, if you look here at this plot over time, how well it performs on a benchmark for medical exams. This went, and notice the x-axis, right? This went from 2 years, right? We're talking early 2021. Went from by and large useless, 30% correct, right? If you translate that linearly to a grade, right? That's certainly failed on pretty much anywhere in the world, to essentially very, very good, right? 90% correctness. And this is work in progress, and it's kind of hard to imagine why there should be an artificial limit there going further. And so if this was tested, actually assessed by humans, it has very high quality answers on almost any measurement that you do this. Now, my last point I want to make is these open source models. That's a big development now, probably the biggest actually. Because otherwise I've just been talking about ChatGPT, but of course there's now a huge development in the open source space. And interestingly, the world seems to be divided by those who think, thank goodness we have this open source model, because otherwise, right, we'd all be doomed and basically slaves to these companies that have absolutely control over what we'll do in the future. And then others say, no, it's actually these open source models that we need to be worried about, because now anyone can take them into their basement and help it, right, create the next, virus or what have you. So again, a lot of confusion, and I don't think there's correct answers. But this is the timeline, and I want you to notice just how quickly that went. I mean, we're talking about March 3rd, when the first series open source model was leaked by the company who owns Facebook and Instagram. And then the academic world jumped on this very quickly, started fine-tuning these models, because again, they cannot train them. It costs millions of dollars. It probably costs about $100 million to train GPT-4. But they fine-tuned it, improved it further, and they've been doing very, very well. And just a few weeks ago, Meta released Llama 2, which has now become the standard in the open source world. So just right in terms of the words or names you'll hear is GPT, right, which comes from OpenAI, which largely belongs to Microsoft. Then there's the Bard world from Google. There's Claude, which is very competitive. And then there's Llama, which is open from Meta. And when you look at benchmarks, how these things do, then you can see GPT-4 is still the leader in this field, and by a good margin, but the others are catching up. So this Claude is catching up quickly. GPT 3.5 just behind, but then you can see Llama immediately coming in there. And this is interesting because now you can see, right, all the really top performing ones are proprietary. But then the other ones down here, they are open source, but you can't use them for commercial purposes. That's what's so interesting about Llama 2, is that you can use it both commercially and for research. So when you just go to meta.com, right, you can download the model for free for research and commercial use. This is quite amazing. I mean, I don't think people understand quite what a big deal this is. I mean, this is technology that's kind of alien to us, and I don't think it has sunk in yet how much that will change everything. And yet here I can download it for free, which is just fascinating. This is very, very, costly again to produce, and is part of the reason why the world is really clamoring for these GPUs. Roughly speaking, you need about a byte for each parameter, two, sorry, which is why for a 70 billion model like Llama, you need 150 gig of RAMs, which you don't have on a normal computer, but you have on these large GPUs. So you can't just download this and run it on your computer. You can run a 7 billion model and a 13 billion model, because you have probably maybe 24 gigs of space, but then you're very quickly stopping. And these are nowhere, right? These are little toy models. They will not give you correct answers the way GPT does. You need GPUs to run these models. And in particular, you need one type of GPU from NVIDIA. And that's why you may have heard that there's another $1 trillion company. It's not just because it's a cool chip, but it's actually everybody who wants to do this kind of AI needs to buy those chips. And so there's a huge demand for those. Okay, let me finish up. There's an interesting, this just recently happened for those of you who are working with data, which I think many of you are. There was a tool released in ChatGPT that's called Code Interpreter. Should actually be called Data Interpreter. It's extremely fascinating because now you can upload files. That's new. You couldn't actually upload files. And when you do that, right, you can reason through these files, because the code interpreter will actually be able to run Python. It won't be able to run R yet, but I'm sure that's coming any moment. So you can say, please analyze this file. Please make this and this statistical test. I'm looking at how high it correlates with this. It will do all of these things live. And then you can say, no, that's not, what else am I not seeing in this data? And it will come up with things that you haven't actually seen, which is quite fascinating. I encourage you to explore this, and I'm fairly certain that there won't be, right, sort of looking forward into PhD supervision. It's hard to imagine that anyone will do sort of data analysis without this in the future. You can now also fine-tune the model with your own data, which I think is going to be very powerful, but don't want to go into the detail. Let me finish with two slides, one on research and one on health. So in terms of research, I think there's a couple of points. The first is that you will increasingly not see this technology at work. Why is that? Because right now it's in our face, right? It's ChatGPT, boom, here it is. What can I do with it? But increasingly, when this new technology comes along, it gets integrated deeper and deeper and deeper and deeper and deeper into the stack. And it's doing its thing, just like it did before, but you're not interacting with it anymore, right? In the same way that in the very beginning, you interacted with a computer, in a very complicated and direct way, or with the internet, right? You had to like type in things, or email, where you had to remember numbers and things. And now it's basically a screen and a button. Still the same technology, but everything has been integrated further down the stack. And that's what's happening with LLMs that are integrated now into software. And at some point, you don't realize that there's an LLM working behind the scenes. Supposedly, there's probably, I don't know what version of Zoom we're using here, but there's probably an LLM making sense of what I'm saying if it's the latest version. It can also produce well-structured data. This is interesting, right? For the data scientists among you, you have to guarantee that it's consistent, but still, that's extremely powerful. They can hallucinate, which is maybe something we can discuss. That means they're creative, right? That's the same coin. You need to anticipate this. And so I think that overall, the role in data analysis, writing and summarizing is likely going to be quite revolutionary. Now, with respect to health, right, there's many aspects we could look at. The three that I think are very powerful. One sounds perhaps a little boring unless you're actually in the field doing work, but which I'm not. But I've seen this many times, and I'm being told that much of the medical practice is capturing data and entering it to an electronic system, and absolutely everybody hates that, and it takes time. And it's to some extent now trivial to do that automatically because you can now just have audio and LLM essentially capturing and storing this data. So again, there I think we'll move into an area where it'll be weird for any medical professional to type something into a computer while they're working with patients, which I think will overall be a very good thing. Now, these medical networks, of course, will also bring the medical and scientific information to the masses in ways that we haven't seen before. Again, there's nothing that stops me, right, from saying I have this medical problem and I am a medical doctor. What do you say? Like, how do you want to? I mean, of course, you could fine-tune the model to say if the user says he or she's a medical doctor, right? Do not take this seriously. You could do that. But I doubt we will see fine-tuning in this sense. So very clearly, right, that we will soon see papers and reports in the media, just like we did 20 years ago when there was this big moral panic about Dr. Google will see you now, and now it's completely normal. It's that many people will use ChatGPT for medical advice. Completely predictable because health is the #1 aspect that people search on the web, and it's hard to imagine that this will change with this technology. Also, how we ingest and produce textual information has changed forever. That is also something that I think people haven't quite realized yet, that this is actually a new paradigm. So for example, you can see websites like Stack Overflow and Expert Fora and so on just collapsing in traffic because people are going directly to this new interface. And of course, you can say, well, that's a problem because they scrape this data and they learn from it. And I would agree with you. This is actually a problem. But there's very little doubt, I think, that interacting with information in such a way where you either type something into a box or even better, you just speak it, is the way we will interact with machines. I think this idea that this should somehow be the future of human interaction with a computer, right, is kind of ridiculous. I mean, it was useful for a couple of decades because there was no other way, and this was also kind of smart, but it's not natural, right? We won't interact. People don't want to take a keyboard. They want to talk to software, and that's what LLMs will do. And I think that hasn't quite integrated into people's thinking yet.
Thank you, Marcel. I was struck by the last comment you made because many years ago, when I did my PhD, I wrote my comprehensive exams using dictation software. I didn't use a keyboard. So I spoke my responses to the questions of my comprehensive exams. And I kept thinking that, wow, this is the way of the future. And we're still talking about that being the future. It's incredible how fast we are, but then how slow we are.